All right, so we're quickly looking at the reciprocals of other functions. And so I've sort of taken a bit from the Hazy textbook, where we can look at an investigation, so we can sort of discover these together. So if you've got the Hazy textbook, do this and pause the video as we go. So you can, I'm sort of going to go through it, but you can definitely like pause it, do it yourself, and then check. So the definition we've got, the reciprocal of the function f of x is 1 over f of x. So the first question in the investigation is compare the graphs 1 over y equals x and y equals 1 over x. And so I've just got my graphics calculator to the side here, and I see I've got y equals x there. So 1 over x goes through this coordinate of 1, 1, but then it looks something like this. Now on the negative side, it also goes through this coordinate here, which is, we've got this coordinate here is -1, -1, and we've got 1 and 1. Perfect. Now, looking at the graph, we can sort of see that x can't equal 0. So we would see, I'm going to use this color here. This would be an asymptote here. So the function would never equal that. And we also have that as we approach infinity, you sort of see that it peters out. So we would never go past these here either. Now, let's go to the next one. We've got y equals x plus 2, which I've graphed already. Now, if I change this, I'm going to change this in my graphics calculator. I suggest you do the same if you're doing this. So I've got y, x plus 2, I draw it. Now, I end up with the same thing as before, apart from I have this asymptote here, which I'm going to represent with a dotted line, and I'm going to x equals -2. And so, as expected, when this function equals 0, we end up with an asymptote. You'll notice here, if I do my intersection points on my calculator, I have this intersection here. I'm just going to sort of extend over. And this coordinate that they intersect at is -3 and -1. And we see here, it goes through this coordinate here, which is -1 and 1. And if you look at this, it's actually the same graph as this. It's just been translated 2 units to the left. Let's go to the next one, x minus 2. We see the same thing here, so change it in your graphics calculator. All right, so just going to quickly change it in my graphics calculator, and I see the same value here. I see this asymptote here, but now instead of it being 2 units to the left of the origin, it's now 2 units to the right. So we see this translation, which we sort of expect from this value here. So x equals 2 gives us an asymptote. We see this intersection point here. And you'll notice that it's sort of, we're seeing 1 unit over, 1 unit up from the asymptote, same 1 unit over, 1 unit down. So it's sort of, we get this idea around this. So pattern that out. Again, we've got those asymptotes there. Cool. Now this next one here is a little bit different. We've got 3x plus 4. So I'm going to quickly put that in my graphics calculator because the reciprocal is a little bit more complicated. So 3x plus 4, I put that in. I've got my function, I go gsolve, intersect. All right, so I've got this value that they intersect. So I get an asymptote here at 4 over 3, which is what I would expect, -4 over 3. So x equals -4 over 3. And then I have this intersection here between the functions. So you'll notice that it's sort of dilated, like instead of it being up here at 1 and sort of 1 across, we now have a different value here, that this value is, I've drawn that not quite right. Sorry, my bad. And that would -4 over 3. Let me just get rid of these. Okay, so that bit's right, but we actually find that the intersection is here at -1, and it comes out here. So this coordinate here is not -4 on 3, -5 on 3, and -1. And then this coordinate here is where they intersect, which gives us, it ends up being -1 and +1. So you notice here that the y value still ends up being 1, but it changes the x coordinate of that. But as long as we know the asymptote sort of gives us 0, so if I look at the observations we're meant to get out of this, so in the investigation we're meant to compare these graphs, and hopefully we've noticed some of these things. So we notice that the zeros of our original function become a vertical asymptote of the reciprocal function. So here's a 0, that gave us this asymptote. 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 And then we've got this other rule over here, which sort of says, well, we've got these ones here. When f of x is positive, the reciprocal is positive. And when it's negative, the reciprocal is negative, which you see in these functions, they both follow that same trend. So we end up, maybe I should pick a different color. We'll go this one here. And so that is positive while that's positive. This is positive while this is positive. I'm just going to get rid of them because I feel like, oh, actually, no, that's not too bad. I don't think it's actually not super blatant. So positive, positive, we've got a little positive. These are positives. Positive, positive. Now we'll pick a different color for the negative. Sorry, you're seeing me highlight. Let's just go this pink. So when they're negative, so we see this value here, negative, 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 negative. And so it's good to know that that's a really easy thing for us to look at. And now, do we have anything else? F of x approaches, no, we're all good with the next one. So then the next bit here, we're looking at slightly more complex functions. So we're looking at, our first one here is x squared. So let's put in x squared into our calculator. Now, I should have actually mentioned, I've got y1 in my graphics calculator equals x squared, and then I've got y2 equals 1 over y1. Easy way to do the reciprocal of those functions. Now this here, I get this asymptote here at 0, and I get a function that goes like this. Now, when we come to graphing these, it's not specifically mentioned, but 1's a really good value. 1's, obviously, when our original function equals 1, if we divide by 1, it becomes easy to sort of find that coordinate. So I've got that there. All right, then let's go to the next one. We've got, let's graph this one really quickly. So we've got negative bracket x minus 1 squared. So this is like a double transformation in that if we just went negative x squared, it would be a reflection and we would have a downward function. But this is not just that, it's also negative, and then we transform at 1 unit. So this one here ends up being negative like this, but we have the same thing here. We have this asymptote here at x equals 1. And then we also see this function goes like that. And then this function goes like that. I've drawn this a little bit poor because, as I said before, we sort of look at those 1's easy for the reciprocal function. Now, next one, we're going to do the graph. We got x squared plus 4. And so I draw that. Now, this one's really interesting that I end up with this function. I'm going to draw this not to scale. So it would be down here, but I'm going to draw it a bit bigger just for this sake. Let's just say that's a quarter. So obviously this scale is wrong. I'm going to write not to scale. And we see this function goes like this here. Now, obviously our max here, it's interesting, this 4, which is our minimum, becomes our max here, but it's 1 over 4, which is an interesting point to look at. Next function, we've got this value here. What do we got? Negative bracket x squared minus 4. Now this thing ends up being a bit more complicated. We end up with these asymptotes here. Now, my function's not quite drawn again to scale, so this value here will be 2, and this value here will be negative 2. And I know that because negative 2 squared will be 4. 4 minus 4 will be 0. So the zeros here will give me those asymptotes. Now I'm looking at this positive value here. This max here of my function would be 4. And so I would find that my min here is going to be, I'm going to do again a quarter, but this time it goes like this. We see this function goes up, and then on these other ones here, we end up with this value like so. Okay, now I'm just putting the intersections in. I end up with this one down here is a x value of 2.23. It doesn't look like a decent value. I will point out that these values here of the intersection happen at y equals -1, which is kind of interesting, but we will leave that like that. Oh, and these points here where they intersect, well, obviously not to scale again. These values here happen at y equals +1, which is pretty crazy. So interesting that when the functions both equal each other, well, let's consider this for a minute. So I will just quickly do this. This is a bit of a tangent, so I'm going to just copy these. It's interesting to think that, why did that not just copy? Let's just paste this down here. So we're looking at these functions. It's interesting to think when they intersect, we've got negative x squared minus 4 equals, we're looking at the y, no, we're looking at the x, no, we're looking at the y values that equal the same. X squared minus 4 I'll leave that. I'm having a mental blank at the moment. I will come back to this. All right, let's go to the next bit. So here we've got a function in a good form for us graphing. We've got bracket x minus 1, bracket x minus 3. So easy one to draw the intersects. And this function has an intercept here. Oh, why have I changed color? So x equals 1, and then we have another value here at x equals 3. Now it's interesting here that this value here is going to be this value down here for this function, our original function. What value will that be? G solve intersect, they touch at that point. So it's interesting that this happens at 2, which we should know, and then they intersect at -1 again, which is pretty good. So we've got that there, and then this function here, same deal. And we look at that again, and that is all the functions there. So when you look at these ones here, these next ones were interesting because local min of f of x, so this one here has a local min, that would become the max, but there's an asymptote there. Is there another one that has, this one here has a local min, which becomes the max there. Now this next bit here, we look at the local max this local max becomes that local min. This local max would become that local min, but there's an asymptote. This local min becomes that local max. So interesting there. All right, now vertical asymptotes of f of x. We didn't have any f of x functions we graphed with an asymptote. When f of x approaches 0, the reciprocal, so it's interesting that we approach infinity. So that's pretty much the definition of an asymptote. So as our function approaches 0 here, we notice that it approaches infinity. I should have picked a different color there. Let's go to this thing. So these ones here, you notice the function here approaches 0. And here, and we end up approaching infinity for each of those ones. So we just need to work out those values. All right, jump into those questions and have fun with these, guys.